Our next rule is a proof of the constant multiple rule. What we'd like to show is that the derivative of some constant times some function has to equal that same constant times the derivative of the function. Right, so this would be an example of this might be something like if f of x equals 2x squared, then f prime of x equals the constant 2 times the derivative of just x squared. And the derivative of x squared is 2x, so this would be 4x. Right, so this is what we're setting out to prove. So the proof works something like this. Let's say that g of x is equal to some constant times f of x. And what we're trying to show is that the derivative of g of x equals c times the derivative of f of x. If we can show this, then we've proved it. Well, g prime of x must be equal to the limit as h goes to 0 of g of x plus h minus g of x all over h, and f prime of x must equal h, the limit as h goes to 0, of f of x plus h minus f of x all over h. Now, if we were to take the constant c and multiply it by both sides of this expression, then we would have the limit as h goes to 0 of our constant times f of x plus h minus the constant times f of x all over h. But c times f of x plus h minus c times f of x is equal to g of x. So this must be equal to the limit as h goes to 0 of g of x plus h minus g of x all over h. So we've proved the rule. Let's do some examples. If y equals 2 over x squared, and we'd like to take the derivative of this, personally I prefer to rewrite this as 2 to the x times negative 2 power. And by the power rule, I'm going to drop the exponent, so I will have 2 times negative 2 times x, and I need to decrease the power by 1, so this will be to the negative third. And when I simplify, I end up with negative 4 over x cubed as the value of y prime. Example B. If we say that y equals 4x cubed over 3, the constant in this case is 4/3. F of x equals 4x cubed over 3. So f prime of x must equal the constant, in this case 4/3, times, using the power rule, 3 by bringing down the exponent, and I'll be decreasing the exponent by 1. And when I simplify, I end up with 4x squared. Example C. S of t equals negative t to the fifth. Well, the constant here is negative 1, so f prime of t must equal negative 1 times, applying the power rule, I'll bring the 5 down and decrease the power by 1. Simplifying, we have negative 5t to the fourth. Example D. Y equals 4 times the square root of x, and now I'll rewrite this as 4x to the 1/2 power. The constant here is 4, so y prime must equal 4 times, I'll bring the power down, which is 1/2, and decrease it by 1 to negative 1/2. Simplifying, this cleans up to 2 over x to the 1/2 power, or 2 over the square root of x. Example E. Y equals negative 5 over 3x cubed. I'm going to rewrite this as negative 5/3, which is the constant, x to the negative 3 power. So this means that y prime must equal the constant, negative 5/3, times negative 3, bringing the power down and decreasing it by 1. And when this gets cleaned up a bit, we're left with 5 over x to the 4th power. Example F. F of x equals negative 5 over 3x quantity cubed. And if I clean this up a bit, this is the same as negative 5 over 27x cubed. And making a couple of adjustments, this is equivalent to negative 5/27 times x to the negative 3. This means that f prime of x must equal the constant, in this case negative 5 over 27, times the exponent, negative 3, times x to the negative 4, because I'm decreasing the exponent by 1. When I simplify to clean this up, I'll end up with 5/9 times x to the negative 4, or 5 over 9x to the 4th. Next we've got s of t equals 4 over radical t, which is equivalent to 4t to the negative 1/2. So my constant in this case is 4. S prime of t then must equal 4. I'm going to bring the exponent down, so times negative 1/2 t to the negative 3/2. And when I simplify this a bit, we're left with 2 over t to the 3/2 power. Or you could rewrite this as 2 over the square root of t cubed. Personally, I would use exponential form, but they are equivalent. Final problem, example H, y equals negative 12. It's the cube root of x to the 5th. I'm going to write this as x to the 5/3 power, and that would be equivalent to negative 12x to the negative 5/3. So my constant is negative 12, which means that y prime should equal negative 12 times negative 5/3, bringing the exponent down. And when I subtract 1 from that exponent, I'll have negative 8/3. Cleaning all of this up, we end up with 20 over x to the 8/3 power, or if you prefer, 20 over the cube root of x to the 8th. So we have the constant multiple rule.